Hi everyone, my name is Austin Black, and I'm a solutions engineer here at DigitalOcean, coming to you from Canada. I'm excited to speak with you today about a very popular e-commerce platform, Magento, and some of the different ways it can be deployed. Some pun intended. Magento is one of the most common choices for e-commerce, and it's easy to see why, given how powerful and customizable it is. It can be deployed as a monolithic application, more on that later, or it can be abstracted into different layers, which we're also going to do. So, that all being said, let's get started. All right, here's the agenda for this talk. We're going to discuss some various terms that you may or may not have heard before, as well as why they matter. We'll cover some examples of what a Magento deployment can look like, especially in regards to scaling. We'll also talk about how managed services can make your life easier and why you'd want to use them. We're also going to compare the setups listed in here with Magento Enterprise. Lastly, we'll discuss a few other key points that you'll need to consider to get up and running on Magento. So first and foremost, we have high availability. High availability essentially means that we want to guarantee some level of uptime for our application, even in the face of adverse events like maintenance or other issues. Secondly, and relatedly, is failover. Failover occurs when a component, fails and another piece needs to take over. Essentially, it's part of design for redundancy on purpose. Third, we have NFS and DFS. NFS refers to network file system, while DFS refers to distributed file system. While they occasionally tend to be conflated with each other, they do have important differences. With NFS, you open a mount point for data to be accessed through over the network. With DFS, the file system is distributed across multiple nodes. DFS implementations can vary based on the end architecture's requirements. You can have your data spread out across nodes, that's where the distributed comes into play, and you can also have data replicated across nodes for further redundancy. You can expose a distributed file system via a network file system, which is key to a few implementations. We also need to talk about content delivery networks, which is a way of delivering media and other files like static CSS and JavaScript files faster and more efficiently to users of your site. DBaaS, or DBaaS, refers to Database as a Service, which we'll discuss as part of the managed services later. Finally, a monolith refers to a setup where the entire application is hosted on a single server. So a key consideration for systems architecture is designing for a system that has tight cohesion, loosely coupled. What this means is that all of the pieces work well together, but they're not fully dependent on each other and can be swapped out as needed. This leads into our next 2 points, which is scalability and failover at individual layers of that system. Having adjustable components is important because it positions you better to take advantage of new tech and remain flexible during upgrade periods, or if you need to make large changes to how your store operates. And so here we see the base case for Magento, which is a monolith. All of our components are being hosted on a single system in this case, which is fine for trying out the software and getting started, seeing how the control panel feels, etc., but it isn't really viable to run a storefront off of long term. This is what you get when you use our marketplace image. From here, it's up to us to abstract out each layer and set it up to meet our criteria. Let's talk about these components. So the web server is just that, the actual server serving your application. For Magento, this is almost always Apache or Nginx. Then we have the database. This is always MySQL or one of its similar variants like Maria. Of particular note, Magento has a feature where you can store your media in the database, which we'll discuss more later. Finally, there's the trickiest piece in my opinion, which is the file system. There are 4 directories that we're concerned about. var contains information on caches, logging, sessions, etc., and should not be synchronized across nodes. But if using a shared file system across your nodes, it should be shared across all nodes. We don't want nodes overwriting each other on it, but if they can all contribute to the same location, then that's okay. app/etc needs to be synchronized as it contains configuration files. This can be done with careful configuration of a tool like lsyncd, or you can just use a shared file system to just skip this entirely. Pub contains public files, as the name implies. Media contains the media, of course, like photos, etc., which we can offload to the database, as I mentioned, while static contains CSS, JavaScript, etc. files. Those media files, those static CSS and JavaScript files, those are exactly the kind of content we'd want to serve with a CDN. So we just saw the monolith. Let's assume that we have one of those up and running right now. Here's how we can start scaling out from here. Before anything else, we're going to need the database cluster. This is pretty straightforward in DigitalOcean. and it provides you with a database cluster that's maintained for you. My coworker and good friend Alexis Reyes is giving a talk here at Deploy on our DBaaS and how it works, so if you want a deeper dive on it, go check out his talk. And so once that's been created, here's what we need to do to make it useful to use. We go into our currently running monolith and we kick it into maintenance mode. Once that's done, we know the database can't be written to anymore. At that point, we can dump our database, but we're not ready to import just yet. This part can be a bit tricky. A SQL dump is really a way to recreate and replicate that database to a new server. It's not just its current collection of tables. If you look inside a dump file, you'll find the calls needed to create tables, create views, etc., etc. As such, we need to prep it to work with our new DBaaS instance. We'll need to update all of our views to use an existing user on the cluster. DO admin is the default, but you can create your own users as you choose. We'll also need to update any references to localhost as a source to the new database cluster. You can use the %sign or the wildcard for any length of characters here to get going again quickly. Fun fact, even though I just said wildcard for any length of characters, localhost is explicitly excluded as a special string in MySQL. So once all of our views are adjusted to use a valid user and host, then we're ready to import into our DBaaS cluster. And so now we need to configure our Magento instance to use it. This is done by taking the connection info from our DBaaS instance and updating our application to use it, which is done in app/etc/env.php. env is an environment, just shortened to 3 letters. So one key thing to note here is that DBaaS supports both public connections from external to DigitalOcean or over the private network, or VPC. The private network, VPC, should absolutely be used here to both save on bandwidth costs as well as help secure our infrastructure. Once our instance has been configured to use our DBaaS cluster, we can go into our Magento instance and configure it as a media store. We should also make any other configuration changes that we need at this time, because we're about to take a snapshot of our current system. After that, we can create more servers based on that snapshot. Optionally, we can also create a custom image from the snapshot for archival purposes or to create more servers in future, assuming that the image doesn't need to be updated. Lastly, we're going to put a load balancer in front of those web servers so that they can share the workload. And so here's what that would look like in practice. The user will hit the load balancer now before being sent to a web server, which is now leaning on a managed database instance. Our managed database holds our media store so that we don't have to worry about propagating media across our other nodes. The prior considerations for the file system still stand, though. I also want to highlight a few other concepts at this point. First, DigitalOcean offers the ability to tag resources. This means that you can apply a label to a resource and have it grouped with other resources with the same label. This is important for our second concept, which is trusted sources. DBaaS supports the ability to filter incoming connections, either by IP address or by tag. By tagging resources and then only allowing resources with that tag to connect to the cluster, you greatly enhance your cluster and overall deployment security posture. By doing all of this and ensuring that you're using the private network, VPC, as stated previously, you greatly reduce the attack surface of your deployment. And so now we can scale our web server layer out. All we need to do is add more web servers from our prior snapshot and set up the file system syncs accordingly. Adding more nodes behind the load balancer like this is an example of horizontal scale. In addition, we have redundancy so long as 2 or more web servers are up at that layer. Lastly, since we're using DBaaS, we can achieve vertical scalability on the fly. More on that with the next slide. So now our web server layer is redundant, but our database layer is not currently. However, with a managed DBaaS service, you can add standby nodes on the fly. This ensures that in the event of maintenance or hardware issue, a second node will be ready to take over. This greatly contributes to our Magento instance's high availability. Secondly, DBaaS also allows us to add more resources on the fly as we need. This is an example of vertical scale when you add more resources to a single node. If we find that we're running out of RAM or we need more processing horsepower, it's as easy as making an API call or adjusting a dropdown in our cloud panel to get more resources. And so this is how adding the standby node changes our server topology. It doesn't actually appear to be a significant change, but it's really very important for our system to be highly available. And so now let's kick things up a bit. Let's say that our store's matured, we're getting more customers, and our database is having trouble keeping up due to serving our media files in addition to its regular duties. With this diagram, we're adding a separate file system cluster labeled media here, but it's really for all 4 of those directories I mentioned earlier. This can be as simple as running a droplet and using its local disk for your NFS, but to ensure high availability, a distributed file system like Bluestar or Ceph should be used. You can use DigitalOcean volumes here to enhance this, which is another example of a managed service. I highly recommend that you use volumes here as they're secure, easily expanded, backed by redundant storage, and hosted on separate hardware from your droplets. They're also easy to take backups of via snapshots. And so the base case for a DFS here would be as simple as 2 droplets, each with 1 volume attached. You would run Gluster or Ceph on those droplets using the volumes with full replication. This means that both volumes will contain identical data. When one updates, so does the other. You would then configure NFS on both of those droplets and have them serve the mount point accordingly. So this all contributes to our high availability. In the event of maintenance or unforeseen issues, having failover is extremely important. And this is where things can really start to get complicated, but we do have a full solutions engineering team, which I'm proudly a part of, who can assist you if you're looking to deploy something like this on DigitalOcean. And so we've done all that now, but our database is still struggling, and we don't simply want to throw more resources at it to solve the problem. Magento also works with Redis for caching our pages, which can take some more work off of our MySQL cluster. We also offer a managed Redis service, which greatly simplifies setting it up and working with it. And so now, let's tie it all together. At this point, your store is getting tens of thousands of visitors. DigitalOcean's load balancer is no longer enough. We're going to ensure that we're using a CDN to cache as much content at the edge as possible to save both bandwidth and response times. We're going to add an HA proxy pool in front of our web servers to replace our prior load balancer, which can also scale as needed. HA proxy is an open source, very common load balancing technology that can work in a clustered setup, so it also becomes an individually scalable layer. Otherwise, though, the rest of our architecture doesn't really need to change. We may need to add more nodes or otherwise scale accordingly, but each piece can be adjusted individually without much fear of unintended consequences within reason. Obviously, if you destroy your media store or your database, you're going to absolutely ruin everything. Take backups before you make these kinds of changes. Like, seriously, no IT person, no DevOps person will ever fight you on taking backups. You should take them as much as you can within reason. But overall, this architecture exemplifies tightly cohesive, loosely coupled. If you want to change your file systems, you can do that. If you need to move off of managed Redis or MySQL, you can do that. All of these pieces can be treated relatively atomically. And so, for your consideration, here's the official diagram provided for Magento Enterprise Edition. It's really not that dissimilar to the prior diagram. There are a few different pieces, such as Elasticsearch being included, but for the most part, the previous diagram and this one are actually fairly close. And so Elasticsearch is something I want to draw attention to in particular. As of Magento 2.3, it was optional for catalog search, but as of Magento 2.4, it's required. This does add some additional complexity and requires additional resources. It'll also require special configuration of your web server of choice. As such, please be aware that Magento 2.4 does have a higher bar to get started than Magento 2.3. Magento 2.3 does support Elasticsearch though, so you can implement it when the time is right for your store. Secondly, security and patching. While we do want everything to remain in sync, this design does allow us to down individual servers for patching and maintenance. The load balancer will simply stop serving requests to that server so that others can pick up the slack. Always enable maintenance mode before making these types of changes, and again, take backups. Really take backups. Lastly, for testing your site, you can use tools such as Loader.io to get a feel for how much traffic your site can handle and when it will be time to scale up. And so our final infrastructure is very flexible and adjustable while leveraging managed services in order to ease some of the common pain points, such as database failover. There are a few other things you'll want to consider as well, such as what you want to use for a payment processor. PCI DSS is no joke, so using a vendor like Stripe or PayPal can make that much easier. I mentioned at the start of this talk that Magento is highly customizable, with lots of plugins out there. If a plugin you need doesn't exist, it's likely that you can find someone who can build you what you need for you. And lastly, Magento can be further optimized with additional caching layers, such as Varnish for an edge file cache or PHP's APCU to speed up web server operations. And so, all in all, I hope this talk was helpful. This is what a growth plan for Magento can look like, but by no means is it the only way to run or maintain Magento. Ultimately, it will be up to you to decide what's right for your business. Please feel free to reach out to my team and I if there's any questions about what we can do for you. Thank you for listening and have a great deploy.